Alright, in this video I'm going to be talking about some algebraic tests that we can use to test for symmetry whenever we have an equation that's graphed on the plane. So what I mean when I test for symmetry is I'm going to see whether or not the equation reflects over the x or the y-axis. So if I have an equation like this, if it's symmetric about the y-axis, that means if I flip it over the y-axis, this part is going to coincide. So it'll look something like this. That's symmetry about the y-axis. And symmetry about the x-axis works the same way, except if I flipped it over the x-axis, then the graph would coincide. So notice if I have a point on the graph, call that xy, if it is symmetric about the x-axis, if I were to point a line down to it and draw another point on here, then I'd have the same x-coordinate, but the negative version of the y-coordinate. And if a graph is symmetric about the origin, then it would be symmetric about both the x and the y-axes. And that point that's symmetric about the origin is going to be negative x, negative y. So let's go through a few examples. Let's say that I have y is equal to negative 4x plus 2. So I'm testing for symmetry about the y-axis. So if it's symmetric about the y-axis, then if I have a point xy on the graph, then the point negative xy is also on the graph, and they have the same y-coordinate. So what I'm going to do is I'm going to plug in negative x in the function and see if I get the original function back. So I'll have negative 4 times negative x plus 2. And this is going to give me 4x plus 2. And this is not the same because I have a 4x on one side and a minus 4x on the other side. So it's not symmetrical about the y-axis. To test for the x-axis, it's the same idea, except I'm going to plug in negative y in for y, and then solve for y. So I'll have negative y is equal to negative 4x plus 2. And then to solve for y, I divide through by a negative. And when I do that, I have y is equal to 4x minus 2. And it turns out that that is not the same as our original function because both of the signs have changed. So it's not symmetric about the y-axis either. It's not symmetric about the x-axis. And as for the origin, I switch the signs of both x and y and see if I get the original function back. So I'm going to have negative y is equal to negative 4 negative x plus 2. So I have negative y is equal to 4x plus 2. If I solve for y, I get y is equal to minus 4x minus 2. And this is still not the same as our original function because the sign in front of the 2 is different. So it's not symmetric about the origin. So this particular function has no symmetry. Let's say that I had y is equal to 5x minus 6. If I want to test for symmetry about the y-axis, I plug in a negative x and see if I get the original function. So I'll have y is equal to 5 times negative x minus 6. And that's going to give me a negative 5x minus 6. And I can see that this is not equal to the original function, so there's no y symmetry. And for x-axis symmetry, it's the same idea, but except of a negative x, I'm going to plug in a negative y. So I have negative y is equal to 5x minus 6. And then when I solve for y, I get y is equal to negative 5x plus 6. And this is not equal to our original function either, because both of the signs have changed. So there's no x-axis symmetry. Now to test for symmetry about the origin, I substitute negative y in for y and negative x into x. So I have negative y is equal to 5 times negative x minus 6. And then I solve for y. So I have negative y is equal to negative 5x minus 6, and then divide through by the negative to get y is equal to 5x plus 6. And this is not the same as the original function either, because the signs in front of the 6's are different. So there's no origin symmetry. And since there's no symmetry about any of the axes nor the origin, the function has no symmetry. Let's say that I had the function y is equal to 7 minus x squared. So to test for symmetry about the y-axis, I plug in a negative x wherever I see x into the original function. So I'll have y is equal to 7 minus negative x squared. So negative x squared is just a positive x squared. So I have 7 minus x squared. And you can see that this is equal to the original function. So we have y-axis symmetry. In x-axis, it's the same idea, but instead of a negative x, I'm going to do negative y. So I have negative y is equal to 7 minus x squared. Then when I solve for y, I have y is equal to x squared minus 7, which is not the same as 7 minus x squared, because the signs have changed. So since this is not equal, we have no x-axis symmetry. Now to test for symmetry about the origin, I set both x and y to be negative. So I have negative y is equal to 7 minus negative x squared. And then I get negative y is equal to 7 minus x squared. And then when I divide through by the negative, I get y is equal to negative 7 plus x squared, which is not the same as our original function. So there's no origin symmetry. So based on what I've seen from my tests, this function only has y-axis symmetry. Let's say that I had the function y is equal to x squared plus 2. So to test for y-axis symmetry, I set x equal to negative x. So I have y is equal to negative x squared plus 2. And this is going to give me x squared plus 2, which is what I had originally. So that tells me that we have y-axis symmetry. Now for the x-axis, I'm plugging in negative y in for y. So I'll have negative y is equal to x squared plus 2. And when I divide through by the negative, I have y is equal to negative x squared minus 2, which is definitely not the same as our original function. And as for the origin, I'll have negative y is equal to negative x squared plus 2, because you switch both of the x and y's out for their negative versions when you test for origin symmetry. It's going to give me negative y is equal to x squared plus 2. And then when I solve for y, I have y is equal to negative x squared minus 2, which we saw doesn't work when we tested for x-axis symmetry. So this function only has y-axis symmetry. Let's say that I had the function y is equal to x cubed plus 3. So the same idea here. If I want to test for y-axis symmetry, I set x to negative x. And I have y is equal to negative x cubed plus 3. The negative x cubed is a negative x cubed. So I have y is equal to negative x cubed plus 3, which is not the same as x cubed plus 3. So there's no y-axis symmetry. For the x-axis, I do the same thing, but I set y to be negative. So I have negative y is equal to x cubed plus 3. Then when I solve for y, I have y is equal to negative x cubed minus 3, which is not the same as our original function, so there's no y-axis symmetry. In a test for symmetry about the origin, I set both x and y to be negative. So I have negative y is equal to negative x cubed plus 3. And so I get negative y is equal to negative x cubed plus 3. And then when I solve for y, I have y is equal to x cubed minus 3, which again is not the same as our original function. So this particular equation has no symmetry. Let's try y is equal to negative 6 minus x cubed. So to test for symmetry in the y-axis, I set x equal to negative x. So I have y is equal to negative 6 minus negative x cubed. And then this is going to give me a negative 6 plus x cubed, which is not the same as negative 6 minus x cubed. So there's no y symmetry. Now for the x-axis, I'm going to set y equal to negative y and then solve. When I solve for y, I get y is equal to 6 plus x cubed, which is not the same as negative 6 minus x cubed. So there's no y symmetry, or there's no x symmetry. And then a test for origin symmetry, I say negative y is equal to negative 6 minus negative x cubed. So I have negative y is equal to negative 6 plus x cubed. And then when I solve for y, I have y is equal to 6 minus x cubed, which is not the same as negative 6 minus x cubed. So there's no origin symmetry. So since there's no symmetry at all in either the x-axis, y-axis, or origin, this function is said to have no symmetry. Let's say I had the function y is equal to the negative absolute value of x plus 2. So I'm going to plug in negative x in for x to test for y-axis symmetry. So y is equal to negative absolute value of negative x plus 2. Well, the absolute value of negative x is just positive x. So this gives me negative x plus 2. And the absolute value of x is just x. So I have negative x plus 2. And these are the same. So I have y-axis symmetry here. To test for x-axis symmetry, I'll say that negative y is equal to negative absolute value of x plus 2. So if I divide through by the negative, I have y is equal to the absolute value of x minus 2, which is not the same as our original function. So there's no x-axis symmetry. If I test for symmetry about the origin, I say that negative y is equal to negative absolute value of negative x plus 2. The absolute value of negative x is just x. So I have negative y is equal to negative x plus 2. And then I have y is equal to x minus 2, which is not the same as negative x plus 2. So there's no origin symmetry. So this particular function only has y-axis symmetry. Alright, this will be the last one. Let's say that I have y is equal to the absolute value of x plus 9. So to test for y-axis symmetry, I set x to negative x. So I have y is equal to the absolute value of negative x plus 9. And the absolute value of negative x is just x. And in the original function, the absolute value of x is also x. So these two match. And then for the x-axis, I have negative y is equal to the absolute value of x plus 9. And if I solve for y, I have y is equal to the negative absolute value of x minus 9, which is not equal to the absolute value of x plus 9. So there's no x-axis symmetry. And then for the origin, I say that negative y is equal to the absolute value of negative x plus 9. So negative y is equal to x plus 9. And then I have y is equal to negative x minus 9, which is not equal to the absolute value of x plus 9. So this function only has y-axis symmetry. So I hope this video was helpful about using some of the algebraic tests that we have to test for symmetry. And keep in mind, if something does have x-axis symmetry, then it's technically not a function because it fails the vertical line test. So all of the functions that I put in are going to have y-axis symmetry or origin symmetry because otherwise they wouldn't be functions. So just keep that in mind. And I hope this video was helpful, and stay tuned for the next one.